We have another example on the board. Again, I'm going to start solving this problem from redrawing the circuit a little bit. I have two voltage sources this time. I have positive 10 volts and I have negative 3 volts. How am I supposed to understand this notation? So it means that I have power supply, right? Just imagine that I have power supply connected to the resistor R1 by positive terminal, right? This is my negative, and of course this is my voltage source 1, which is equal 10 volts. So I can erase this one just in order to avoid the confusion. And I have another voltage source connected to resistor R2 by the negative terminal. Someone is going to ask, why negative? Because I have negative sign over here. And this is my voltage source 2, okay, 3 volts. Okay, so I can erase it just to make sure that this is not going to confuse us. And you have to connect these two voltage sources together. And the connection between them is going to go to the ground. Okay, this is the way how you're supposed to redraw the circuit. Next, we're supposed to check if the diode is going to be forward biased. We have to look at the values of the voltages supplied to the circuit, and we have 10 volts and I have 3 volts. So the sum of these two voltages is going to be greater than 0.7 volts. So it means the diode is going to conduct, and for sure current is going to flow. And keep in mind that the greater voltage is going to dictate the rules in the circuit. It means that it's going to direct the current, in this case, clockwise. Okay, because this voltage source is stronger than this one. Okay, so I have 10 volts. And the current is going to go from positive terminal to negative. Don't forget that we use the conventional current flow. So this is my I total. Next, I'm supposed to just realize that I'm supposed to write the polarities of the voltages across each component. So anytime current is entering the component, I'm going to label it by positive sign. Anytime it's leaving, negative. Positive, negative, positive, negative. So right now we can say that we are ready to write the Kirchhoff voltage law equation, okay, KVL equation. I'm going to start, like most of the time, from the ground, and I'm going to go clockwise. So I have negative voltage source 1, because I'm going this way. Okay, so I have negative voltage source 1. Let me remind you one more time that the voltage across resistor R1 is calculated by multiplying I total times R1. VR2 is I total times R2. Because this is series circuit, I use the same current for both resistors. So I have positive voltage across resistor R1. So I have plus I total times R1. Next, I have plus voltage across the diode plus voltage across resistor R2. So I have I total times R2, and I have negative sign over here. So I have negative voltage source 2 equals 0 volts. Okay, this is the KVL equation for my circuit. Next, I'm supposed to solve this equation for I total. So I'm going to combine the like terms and factorize I total. So I have I total R1 plus I total R2 is equal I have to move my negative voltage source 1 to the right side of my equal sign. That's why I'm going to change the sign. So if minus Vs1 is going to be positive Vs1. And I have positive Vd. I have to move this to the right side, so this becomes negative. And I have negative voltage source 2. I'm going to move to the right side of the equal sign. It becomes positive. Okay. Next, I'm supposed to factorize I total. So I have I total, and I have R1 plus R2. This is equal voltage source 1 minus Vd plus voltage source 2. In order to find I total, I'm supposed to divide both sides of my equation by the parentheses. I have R1 plus R2. And I have R1 plus R2. This and this will cancel out. So I have I total equals voltage source 1 minus Vd plus voltage source 2 over R1 plus R2. I want everybody to be familiar with algebra. This is going to save your life in the future. So I have voltage source 1, which is equal 10 volts, minus voltage across the diode, silicon diode, when the diode is forward biased, is 0.7 volts, plus voltage source 2, which is equal 3 volts. Everything over R1 plus R2, 1.6 kilo plus 5.2 kilo equals I total. In this case, is going to be equal also to IR1. This is going to be equal to IR2, and this is going to be equal also to ID, is equal 1.809 milliamps. This is what I got. Okay, so this is my total current in the circuit. Next, I'm supposed to find output voltage. Output voltage is the voltage between the output terminal and ground. And as I said before, no matter which way you are going to go, you're supposed to get the same value. Okay, so first we are going to go clockwise. So what I have first, I have positive voltage across the resistor R2 minus voltage source 2. Okay, so I have V out is equal positive voltage across resistor R2. We said VR2 is equal I total times R2 minus voltage source 2 is equal 1.809 milliamps times R2, which is equal 5.2 kilo minus 3 volts is equal 6.4 volts. Okay, so this is the output voltage in my circuit. But as I said, there is another way to do it, just to verify that we did our calculations correct. So I can say you can use either or. So I have output voltage is equal negative voltage across the diode minus voltage across resistor R1 plus the voltage of the voltage source 1. So I have V out is equal negative voltage across the diode, because I have negative sign and I have voltage across the diode, minus voltage across resistor R1. We said this is I total times R1. So I have minus I total times R1 plus voltage source 1. This is equal negative 0.7 volts minus I total times R1, 1.809 milliamps times R1, which is equal 1.6 kilo, plus voltage source 1, which is equal 10 volts. This is equal 6.4 volts. As you can see, both answers are identical. So again, it doesn't matter in which direction you are going to go, clockwise or counterclockwise, from the output terminal to ground, you're supposed to get exactly the same answer or very close. At this moment, we can see that we get both of them identical, so it means that our problem is solved correctly.